Alright, in this section we're going to talk about confidence intervals for mean. Basically what we're trying to do now is we're trying to estimate population mean by looking at sample mean. So here we're starting to connect population and a sample. This corresponds to book section 8.1. Worksheet number 18 will have part 1 and part 2. So this is part 1. Okay. In real life, it is often not possible to collect data from the entire population. This is what we talked about in the beginning of the semester. Because population has so many people in it, it's often impossible to survey every single person. That's why we use sample, try to estimate population. So we're actually going to do that today. One of the main applications of an inferential statistic, again, inferential just means educated guess, again, because we're trying to guess something of a population, but it's not like a random guess. We'll have our guess based on the data. Is estimating parameters. Again, parameter is just number you calculate. We calculate from a population, right? Calculate from a population using data collected from a sample. In this course, we will be estimating two parameters: population mean, mu, right, and population proportion, p. Proportion means either percentage or portion, right? So one of the questions I asked before was, what percentage of people in LA have coronavirus? Well, that's a proportion, or that's a portion. Okay, the best point estimate for mu is the sample mean. Again, this is kind of like a review of our notations that we looked at before. X bar represents the sample mean, and the mu represents the population mean. So the best estimate for population mean is the sample mean. Here you see the terminology point estimate. Point estimate means like one particular number, one single number. So what it is we try to estimate the population mean by using one single number, which is a sample mean. And second part, it says the best point estimate for p is the sample proportion. P hat. You notice the p with the little thing on the top is hat. So it's read p hat. The way we calculate p hat is x represents the number of successes or yeses, and n represents the sample size. So for example, if p is the proportion of all left-handed community college students, so that's a percentage of left-handed community college students, and 200 students are sampled with 34 left-handed students. Again, we're not going to be able to survey every single community college students, so that's our population. That's a lot of people. So what we do is we can survey 200 students, and we found out that, let's say, 34 are left-handed. So in this case, 34 is number of successes or yeses. The question is probably, are you left-handed? So the answer is either yes or no. So 34 is our x here, and then n is 200. That's our sample size. So the way we calculate p hat, or the sample proportion or sample percentage, is 34 out of 200. So that's 34 over 200. So again, I can interpret that as 34 out of 200, or that's 34 divided by 200 in terms of calculation, or it's 34 over 200. These three things are exactly the same mathematically. So mathematically, this is equal to this is equal to this, and this is equal to that. So they're all equal. So here what I can say is, okay, from those 200 students, I can see 0.17, which is basically 17% of students are left-handed. So my next question is, do you think that's going to be true for the whole community college students? Well, I'm not 100% sure it's going to be exactly 17% for the entire population, right? Because we don't have data, we haven't surveyed. But my guess is it's probably something close to 17%. So maybe it's 16, maybe it's 18, who knows? So what we're going to do is, instead of saying it's exactly 17, we could say maybe it's around 17, or maybe it's approximately 17, which could mean it could be somewhere between 16 and 18%, or maybe somewhere between 15 to 19%. So that's going to be our strategy. Instead of using a single number to estimate, we're going to use range of numbers. For example, 16 to 18 or 15 to 19, that's range of numbers. And we're going to use that to estimate. That's the next point here. A big advantage of an interval estimate. Interval just means range of numbers, or confidence interval. So you'll hear me saying confidence interval a lot in this class, so I'm gonna highlight that. Hash-over point estimate is an interval estimate, has a confidence level. Oops, let me change to blue. Confidence level associated with it. This number gives an idea of how accurate our estimate is, where the point estimate, we have no idea. Saying you have a 95% confidence level estimate is a statement about the procedure of creating a confidence interval. It means that if you were to repeat this process 100 times, 95 of this created interval will actually contain the population parameter you are estimating. We'll talk about in more detail later about the interpretation of the confidence interval. All right, let's look at number 5. So what number 5 says is that because our confidence interval is estimate and we're never 100% sure, we cannot tell if our confidence interval contains the parameter we're estimating. So number 5 will be false. Let's look at number 6. So now we're going to talk about different components of confidence interval. So we'll talk about critical value, and we'll talk about how we'll use critical value to form this thing called margin of error, and we'll talk about how we use margin of error to form confidence interval. So this is kind of 3-step process. So first step is to calculate this thing called critical value. You notice the symbol is z, alpha over 2. This letter here is called alpha, is the Greek letter alpha, corresponds to the areas in both tails. So when you write it like this. To me, it looks kind of like a fish. The critical value, the confidence level corresponds to the area in the middle of the standard normal distribution. That's why there's the letter Z being used. So if you see the picture here, let's say it's 90%. Let's say we want 90% confidence level. That means we want 90% area in the middle. That means we have 10% area left into both tails. That means each tail will have 5% in it. So, number 7. If you have a confidence level of 90%, what is alpha? Alpha is total area in both tails, so that's 10% because 90% in the middle. That means 10% in the both tails. You can write it as 10%, or you can write it as 0.10. It's the same thing. What's the area in one of the tail? That's 5%. How do I get that? Well, it's just 10% divided by 2. Again, it could be this 0.05. How do you find the critical value? Well, here is the case where the percent is given, and we're trying to find this score here. What is this score? What is this score? Since we're talking about z, is a standard normal distribution. So what I'll do is I'll do inf norm. I'll do 0.90, I'll do 0, I'll do 1, and I'll do center. So why is that? 0.90 is the area. This is mu, which is the mean. This is sigma, which is standard deviation. And I put center there. For some of you guys, you don't have the center option. that means it's only taking in the area to the left. So if I were to do it like that, inf norm 0.05, 0, and 1, and that's it. So for some of you guys, area is going to be 0.05 to the left. Then 0 is the mean, 1 is the standard deviation, and you don't have a center option. It's just left option by default. And when you input this into the calculator, it'll give you two answers. It'll give you negative 1.645 if you round off, and then it gives you 1.645. One is negative, one is positive. It'll always get you the same number, but one's going to be just positive, one's going to be just negative. So what that means is it's going to be negative 1.645 here and positive 1.645 here. For z-score, for the critical value, you can just take the positive number. You can just ignore the negative part because the number will be the same. So I'll just take that. So critical value will be just 1.645 this case. All right, I'm gonna have you pause, work on number 8, and then we'll meet back right after number 8. So what's gonna happen is once we find the critical value, we're gonna use that information to come up with this thing called margin of error, and then we'll go from there. So the concept here is, let me just back up a little bit. Let's say from 30 people are surveyed. I asked 30 students, hey, how much did you guys spend on your textbook this year? Like a bunch of different numbers. Let's say on average, people spend $70 on textbooks. Like this is sample average, right? So again, this is $70 was average from sample of 30 students. So in my head, how about the entire PCC students? I didn't survey everyone, so how do I know how much they spent on average? So my strategy is going to be, okay, I'm going to try to guess it's also 70, but I'm not sure it's exactly 70 for PCC. What if it's 71? What if it's 65? This could be possible. So instead of saying it's exactly 70 for PCC, I want to come up with range of numbers. This is like concept of point estimate versus interval estimate. So margin of error that we're going to try to calculate is like, how much do I go up from 70? Do I go like plus minus 2, so it'd be like 68 to 72, like 2 steps, or do I go 5 steps? So it'd be like 65 to 75. Like, how do I know how many steps to go so that I can come up with like a range of numbers, right? So there's a formula that we're going to be using. It's a structured way of doing it. It's not like a random guess. So here what it says is calculate point estimate. That's the population mean they're going to get, and then calculate margin of error. So once we have that, this is like population mean x bar, point estimate, or it could be population proportion. We'll add the margin of error, then we'll subtract margin of error from there. Subtraction here, not adding it again. So that will give me confidence interval. That's going to be our strategy. So lower is going to be point estimate. So it could be x bar, which is sample mean, or it could be p hat, which is sample proportion, and minus e, which is margin of error. Here it says EBM. I'm just going to refer as E. So for us, E and EBM, they're going to be the same thing. Upper is point estimate. Again, it's either x bar or p hat plus E. So this range of numbers we're going to get, this is going to be my confidence interval. All right. So let's look at the margin of error formula here. Let's look at number 10. So margin of error is going to be given by z alpha over 2. That's the critical value we calculated before, sigma over radical n. So here, this is critical value. Sigma is population standard deviation. Population standard deviation. N is the sample size. That will be the formula we're going to calculate, how we're going to calculate the margin of error. So The margin of error is product of two numbers. First is z alpha over 2, which is number of standard deviation corresponding to the confidence level, which is also known as critical value. The second number is the standard error, which is the distribution of sample means. You recognize the second part. That part comes from the central limit theorem. The reason it's associated with the central limit theorem is because now we're taking a sample and looking at the sample means. That's why it comes from the central limit theorem. All right, let's look at number 12. Okay, they want to create 95% confidence interval. Sample mean is given, standard deviation, and the sample size is given. All right, so I don't even know what that is. X bar is 32.8. Maybe that's like an average age. I don't know, I'm just making it up. Average age or something. Cool, so we got that. So first step is I want to find the critical value z alpha over 2, and they said they want 95% confidence level. So the confidence level is 95%. That means if I had a picture, 95% in the middle, right? So I'll do inf norm, inf 0.95, 0, 1, and then center. So again, this is mu, sigma, and then center. This is confidence level 0.95. Again, if you don't have the center option, it'll be inf norm. That means we have 5% left over, and then when you split 5% into each one, that'd be 2.5%, which is 0.05. So 0.025, 0, and 1. That's left. But anyway, if you do that, you get negative 1.96 and positive 1.96. So we'll take the positive part, 1.96. All right, next step is we have our graph here. We have X bar. Let's say average age was 32.8 years old from my sample of 36 people. What's the average age of everyone? So again, we don't know it's going to be exactly 32.8 for the entire population. Maybe it's 32, maybe it's 34, who knows? So next step is we're going to try to calculate the margin of error. So starting from 32.8, I want to say maybe it's like 31 to 34 or something. So I have to figure out how much do I need to go by, up and down, right? So that's what margin of error does. So margin of error, z alpha over 2 times sigma over radical n. We got our alpha over z alpha over 2, which is 1.96, times sigma is given to us 5.4, and the standard deviation, n is 36. If you calculate that out, I get 1.764. Okay, so that's my margin of error. That means that's how much I want to add and subtract from 32.8, which is the sample mean. So 1.764, 1.764, plus and then minus. All right, so that gives me 31.036 to 34.564. So again, the interpretation of this is just background. From sample, the average age was 32.8 years old. How about the entire group or population? It could be as low as 31.0 something and as high as 34.564. So this is my interpretation. We are 95% confident that the population mean so here I made it up as population average age is in between somewhere between 31.036 years old and 34.564 years old. That's my interpretation of this confidence interval. Alright, so it kind of takes a while to calculate the confidence interval and margin of error, all this stuff, but luckily we have a shortcut. So our calculator actually does it in one step. So how to calculate the confidence interval for the mean? using your calculator. So this is what we're going to do. This is a shortcut. We'll go to Stat. Then we'll go to Tests. Then we're going to go to find the option number 7, Z interval. So is Z because we're using Z-score as a part of our formula for margin of error, and interval for confidence interval. The next one you see is T interval is something else. We'll talk about it in our next lesson. And once you click that, it gives you a bunch of different options. I want to do stats. Here you want to input sigma, you want to input x bar, you want to input n, and you want to input seed level. And this is what they ask, and once you input that, I'll get you the final answer right away. Okay? Alright, I'm going to have you work on number 14, and then we'll meet back at number 15. Alright, number 15. This is basically, we're trying to calculate for n given margin of error. So this is where margin of error is given to you, and they're asking how many people we need to survey, which is sample size n, right? So question is, how many people do we need to survey? How many do we need to survey? So up until now, every question they told you how many people they survey, but like realistically, maybe sometimes this is more realistic where I want a certain margin of error and I want to do research, so I have to decide, okay, am I going to survey 30 people? Am I going to survey 100 people? How do I know how many people do I need to survey? So this formula will tell you how many people do you need to survey to have certain margin of error. So the formula is n is equal to z alpha over 2 times sigma over e, the entire thing square. So when you calculate the whole thing out, that number will tell you how many people you need to survey. And once you get the number, it's not going to be a whole number, but the question is how many people you need to survey. So the answer needs to be a whole number. So you basically have to round up your answer, and they'll get you how many people you need to survey. All right, one last thing. I'm just going to give you a hint for number 16. It's asking blah 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 how many randomly selected Foothill College students must be surveyed. So it's asking how many people needs to be surveyed. Here I'm going to underline one of the phrases here. They want 95% confident that sample age is within 2 years of true population mean. So within 2 years. So what that means is when you have X bar, it says within 2 years. So within 2 means it could be like over 2 or under 2. Right? Right. So what they're saying is, in fact, what they're saying is margin of error is equal to 2. So that's my hint for number 16. All right, so I'm going to have you finish up the rest of the worksheet. Number 9, number 14, and 16.